So sorry for the delay, everybody. We had a couple of technical issues. Thanks for folks that are here joining us in person, and thanks to folks who are joining remotely too. This is going to be Geospatial Data Magic at the command line. This is the second installment in the spring speaker series for the FOSS4G Lab. The first one was Ricardo Oliveira's introduction to QGIS and PostGIS. We're going to tie some things into what he talked about the last time too. The tools that I'm going to talk about will hopefully be related to some of the work that he did and that you learned last time if you saw that one. Before we get started, it sounds like everybody's done this, but if you're joining in remotely, just make sure that your audio is muted. If you go over to that little microphone and click on that, you can mute the audio, and that way we don't hear anything that's going on in the background there. There is a chat feature, so at the end, I'll try to leave a little bit of time if we have some for questions, and you guys can just post them in there. Cool. And before we get started with the workshop, just for anybody that's not familiar with the FOSS4G Lab, this is a new initiative that Rafael Moreno piloted, or is piloting, and it's designed to be a hub for FOSS4G technology in the Denver area. It's linked in with the OSGeo International Network of free and open source labs. So we have resources there. And we have a website up here at the top, this geospatial.uc Denver website. And that's the place to go to find out anything you want to about the lab. We have some events coming up in the spring. We're going to have more of these workshops and webinars. There's some other learning resources and tutorials up there. So definitely check that out. And this webinar, the other webinars, and really any video resources that we have are going to go on this YouTube channel, and you can link to that through the website. But this is going to hold any kind of video resource that we come up with. You can check them out there. And these slides will also be posted on the website as well if you want to take a look at them. The link down here is the link to Ricardo's presentation from a couple weeks ago, getting started with QGIS and PostGIS. So you can check that out if you're interested. I'm not going to spend much time talking about FOSS4G in general. For anybody that doesn't know, FOSS4G stands for Free and Open Source Software for Geospatial Applications. If you're interested in learning more about it in general or the applications of it, the advantages, pros and cons, we have some resources on the website for that as well. There are some webinars and some academic papers that have been written by Rafael and others. And they really give a good introduction to what FOSS4G is, what some of the applications are, what niches it can fill, where it might be better than some proprietary softwares, maybe where proprietary softwares might beat it out in certain respects. So these are some good resources that we have links to on the web there. One of them is a link to a webinar that Rafael did with Dr. Maria Brevelli, who is a professor at the Politecnico di Milano in Italy. And she's going to be giving a presentation in a few weeks on how they use FOSS4G software in Italy and at that university too. So that's definitely worth checking out. She's been a pretty big name in the FOSS4G world. So today I'm going to talk a little bit about these two tools, GDAL and OGR, and what they are. And more generally, we're going to talk a little bit about command line tools for GIS. So tools that don't require the use of a graphical user interface and that you can run from a terminal or a command prompt or things like that. So to start with, what are GDAL and OGR? GDAL stands for the Geospatial Data Abstraction Library, and OGR it's sort of a confusing acronym. It supposedly stands now for the OpenGIS Simple Features Library. Used to stand for the OpenGIS Simple Features Reference Implementation. Basically, it's a reference to the OGR, the Simple Features specification, which is an open source specification for a certain data format. OGR is basically part of GDAL. GDAL is a framework that includes programming libraries, it includes command line utilities, and it can do a variety of spatial functions, including conversion of data, which is mostly what we're going to be looking at today. The distinction there is that GDAL is sort of the overarching framework, but the GDAL tools tend to deal more with raster data, whereas OGR tends to be the vector side of things. So if you're working with vector data, you're probably going to be using the OGR libraries. If you're working with raster data, you're probably going to be working with the GDAL libraries. And basically what GDAL does, the reason why it's called the Geospatial Data Abstraction Library is because it takes all of these different data formats and it abstracts them into its own class, its own type of data format. And then from there, it can turn it into any number of other formats. It can take a shapefile, turn it into the GDAL class, and then from there, turn it into a GeoJSON file, a KML, any number of other things. And the GDAL library supports a ton of different data formats. So this is just sort of an abbreviated list of some of the formats that GDAL supports and can work with. And you'll see some pretty big ones there, like the Esri shapefile, which is now an open specification. Things like the Tiger format that's used by the US Census, CSV, GML, KMLs, GPX, which are GPS device format, GeoJSON. So lots of different kinds of files here. And again, what it's doing is it's taking these all, converting it into sort of one common format, and then exporting it out into whatever you tell it to. So this, I was actually introduced to GDAL through Professor Matt Krusemark in the engineering department. And he's a big fan of this, he uses it a lot. And he calls it the Swiss Army knife of geospatial applications, because it can kind of do anything. It can work with all these different kinds of formats. You can convert data, you can clip data, you can get information about your data. So it seems like more people would probably know about this and be using it. So why aren't more people using the GDAL framework and using the OGR tools? The answer is because it's a command line tool, and people just get super intimidated by the command line. You open up a terminal and people just think that they're going to destroy their computers. So my hope today is that I'm going to show you that the command line is actually not nearly as scary as it seems. It's pretty simple to work with, and the tools that we're going to use all kind of follow a common format, and we'll learn what that is. So to get you guys comfortable with that, we're going to go through how to navigate the directory structure, how to find where you are in your computer and where your files are. There's some tools for finding help about the different command line utilities and programs, and we'll talk about that. And then the big one with the command line, the thing that intimidates people the most is that oftentimes the syntax, the way that you have to enter in these programs or these utilities, can look very confusing at first, and it can be very complicated. But there are some patterns that we can be aware of that'll help us to work with these command line utilities in general. And we'll go through the syntax for specific tools like the OGR tools and some others as well. I'm not going to go through too much about installing GDAL. It actually is a pretty easy process. There are some great resources through the official GDAL website. If you go to www.gdal.org, this is actually a great website for all resources related to the GDAL and OGR libraries and frameworks. And it's got things like user documentation. It has frequently asked questions. So if you're having an issue, probably somebody else has had that issue and it might be in there. It talks a little bit about things like the supported formats. So you can look on the website and see for the most current version of GDAL, what formats does it support. And it also has some descriptions about how the GDAL classes work, the programming classes. So if you're interested in understanding a little bit more about how this works behind the scene, you can get information about that. But if you're just interested in using it, you can go to the downloads link, which will be on the page here. And that'll take you to a page that guides you through how to find downloads for each of the operating systems. And Juan, you're online too. Can you see, is it getting cut off on the left there on the webcam? Okay, so it's just the projector. Okay, cool. So I run Mac, and so I have used the OS X installation, but this web page will give you information on how to install it anywhere. This site actually for installing on OS X on a Mac operating system is the site that's maintained by William Kingsbury. And he actually has this, it's a really great site. It's got frameworks and libraries for all kinds of different geospatial applications. And he's made it really easy to download those and install them. So he has like a lot of Python libraries that are applicable to GIS work. He has the GDAL framework. He has QGIS. And basically what he does is he takes a recent version that's from the source code and compiles it into a binary that you can use to just install easily on your computer. So that's a good site to know about if you're running a Mac and want to install some other GIS software as well. And so if you go to his website, if you click on the OS X link there, it'll take you up here and you can just download the complete framework, and this will give you everything that you need to run GDAL. GDAL does have some dependencies, some other frameworks and libraries that it needs in order to run. You can install those separately from his website if you want to, but if you just download this right here, it'll have everything that you need to run it. And it just installs like any other Mac program. You download it, open up the DMG file. There'll be a README in there, and there'll be something to click on to install it, and it'll take you right through it. So it's actually a pretty painless process. For Windows, there are a few different options. The one that I have found the easiest to use is the OSGeo4W package. And this one is basically a package of lots of different free and open source for geospatial softwares that you can download all at once, and it'll install them all for you. So you can install things like Map Server. I believe GeoServer may be a part of it, but I'm not sure. And you can install the GDAL tools as part of this too. The nice thing about this one too is you can customize it. So if you don't want all of the tools, you can just download the pieces that you need. But the really helpful tool that this comes with is what's called a shell application, which is what we're going to be using to actually interact with the computer at the command line. And the one that's provided by this OSGeo4W package just makes it really easy to use. It actually uses the same syntax as Linux and OS X, which most of the documentation for these FOSS4G software is written for Linux or Unix. And so if you're using this shell, it just makes it a lot easier. The things that you find online are going to be a lot easier to use even in Windows. So let's get started with some command line stuff and figuring out how to work with the command line. And we're going to do this by answering the three big questions of life. Who am I? Where am I? And how do I get out of here? Who am I part is going to be, who is your user? Who are you interacting with the computer as? And what do you have permission to do in there? The where am I part is, what are your directories? What files do you have? Where are you currently working? And then how do I get out of here is navigating around your computer. How do you get from one place to another? So to start with, we're gonna need to interact with our computer at the command line. And to do that, we need to open up in Mac what's called a terminal, or in Windows, we can either use the command prompt, which is the default, or we can use that OSGeo4W shell that we downloaded with that package there. So if you're running a Mac, the terminal is just located, you can either just search for it, or it's located in the utilities folder in the applications directory there. And if you installed OSGeo4W, then you probably have an icon on your desktop that you can just click on. If you don't see that, you can go into your Windows menu and just search for it, and it'll pop up. Cool. And I'm actually going to exit out of the PowerPoint now and do some live demos of some of this stuff. All right. So on a Mac here, I'm going to open up a terminal. Bring that up so you guys can see it here. And let me see if I can make the font a little bit bigger. You know what, that screen is cutting me off, isn't it? Put it out in the middle there. Juan, is that font big enough for people to see online? Okay, awesome. Sounds good. So when you open up a terminal, it's going to open up. And basically, to give you some background, the terminal is the application that interacts with what's called the shell, and the shell is kind of like the interpreter. So it takes what you type in and it interprets it into machine language so that your computer can run all of these different programs. So when you open up the terminal, you're going to get, you can see up on the top left there, that $sign. That's the command prompt. In Windows, it's going to be a greater than sign, probably. You may have, if you open up yours, you may have some other stuff in front of that command line. It may give you your username, might give you the directory that you're working in, but you'll have that command prompt. And the prompt is where you're going to enter in all of your commands. So if you don't see that prompt, it means you're not ready to enter something in. So to start with, we want to see who we are, what username we're using. And this is an easy one. The command for that is just who am I? If you type that in and hit enter, it'll let you know what your username is currently. This isn't super important for using GDAL, but if you start to interact with, say, a Postgres database, it'll want to know what your username is because there might be different permissions for different databases and things like that. For GDAL, it doesn't matter too much, but it's good to know. So you can tell who you are just with that who am I command. And then more importantly for GDAL is where am I? And when you're working at the command line, the directory or the folder that you're currently in is what we call the present working directory. And to get that, you just type pwd for present working directory, and it'll tell you where you are right now. This is pretty typical. In a Mac, it usually opens up to your user directory. In Windows, it typically opens up to the C directory, the root directory. So that's good. We know where we are. We're in my JDuckWare user directory here. And now if I want to see what's in that directory, I can use the ls command. And that'll print out for me everything that is inside of that directory that's sort of publicly visible. So I've got some folders like the applications directory. I've got the desktop folder. I've got some files like the pgadmin.log file there. So this is pretty useful. If I want to get a little bit more information about the stuff that's in there, though, I can use the same command ls, but I'm going to add an option to it here. And this is something that you'll see with a lot of command line utilities and applications. They sometimes will accept different options or flags with that dash in front of them. So I'm going to use the LA option. And this gives me a much more thorough look at what's in that directory. So for starters, if I scroll up a little bit here, maybe. Actually, this is a good spot. So if I look in here, I can still see that applications directory that I saw in the previous view. And if you look over to the left, you'll see there's this kind of confusing code over here. And this is actually the permissions for that directory. So on the far left, it has a D, and that tells you that it's a directory and not a file. And then the 9 spaces after that will give you the permissions for that directory or file. The first 3 are the owner. The second three are group permissions, and then the final three are public permissions. We don't have to worry too much about this. Really, if you're installing things using your own username, you're going to have access to all the things that you need to. And hopefully you won't have easy access to the stuff that can really screw your computer up. So you should be fine. But every once in a while you run into troubles, and if you need to know who has access to what, you can look at that. You can also see who the owner of different directories and files is. So if I look, most of these are actually owned by my user. Some of them are owned by the root user, which is, you actually have to switch users to get into that. And that's usually designed to protect some files that you really shouldn't be changing very often. So directories that have that root owner, probably you're going to need to do a little extra work to change those, which is by design. And then up here too, you'll see there are some files that have a dot in front of them that didn't show up before. And this is also a pattern at the command line. You'll see any files that start with a dot won't show up in your Finder or Windows Explorer, and they won't show up if you just use the ls command, but you can access them. They're still there. You can access them and you can view them here. Most of these, again, they're hidden for a reason. You probably don't want to change them. There is one file that we're going to talk about in a minute, which is this one right here, the bash profile. And this has some settings that you may need to tinker with a little bit if you're on a Mac. If you're on Windows, you won't have to mess with this at all. And actually, just to show folks who are running Windows what this is going to look like, if you are on a Windows machine, you'll see that OSGeo for W shell pop up here. Ooh, it's doing all kinds of crazy stuff. There we go. So if I double click on that and open it up, I get a pretty similar looking shell. And this one tells me which directory I'm in. So I'm in the C directory. I can use the same commands to see where I am, who I am, and what's in there. And this is the nice thing about using this shell. This is what they call a bash shell, and bash is basically a default for Linux and for Macs. It's the language and the application that they use to interpret command line language. And that's what this shell uses. So it'll be exactly the same for the most part as everything that you see for Unix and Linux, which is kind of nice. Yeah, and you can use all the same commands if you want to see more about those files. You can use the ls-la command too. So I won't demonstrate too much more at the command line in Windows. Just wanted to show you guys that it's pretty much identical if you're using that shell. Get back there. Okay, so we know who we are, we know where we are, and now we want to figure out how to navigate around so we can get to different files, we can get to different applications, things like that. And actually, if you're on a Mac, you can use the Command K. Hit Command K and it'll just clear out your screen if it's starting to get too messy. I think in Windows it's CLS or CLR. If you type that in, it'll clear it out. So to switch around directories, just to remind us, so we're in the user directory right now, and we have, say, my documents folder in here. If I wanted to go into my documents folder, I can use the CD command, which stands for change directory. And this is what you use to navigate around to different directories within your structure. So if I type in CD documents, it looks like nothing happened. And this is also something that's very confusing to people if they're starting off at the command line. Basically, if your computer doesn't have anything to tell you, then it's not going to tell you anything. And so if there was no error and there were no problems and there's nothing to report, it's just going to give you a new command prompt. And that's your signal that everything went fine and you're ready to do the next thing. Some of the commands like ls and pwd obviously have things to report, so they do that. But sometimes people wonder if their commands worked. If it shows up another command prompt, then it did work. And just to check, we can check what our directory is again, and we're into documents, and we can see what's in there. So this is pretty easy. We can get deeper and deeper in. If I want to switch into another directory like OGR demo, actually the terminal, if you start typing something and then hit tab, it'll autocomplete for you, which is pretty handy when you're trying to remember directory names. So I can change directories in there. And now I'm a couple of folders deep into my computer. So if I want to get back out of there and go up a directory, up a level, there's a shortcut for that. I'm going to change directories, and I'm going to do 2 dots. And that's the signal for going up one directory. So if I hit that, now I'm back into documents, one level up. And you can change you can chain these together too. So if I want to go up 2 levels, I can use that double dot, use a slash to let it know I'm putting in a new directory now, use another double dot, and now I'm all the way back up in that users directory. So I went up two levels basically. And same thing on the other direction. If I want to go into a directory that's a couple down, I don't have to do it one at a time. I can type in both of the folders separated by a / and it'll take me there. So that's just some basics for navigating around. A couple other shortcuts, the /, if you just use that, or if you use it at the beginning of a path name, it'll take you back to the root directory, to the top directory. So if I hit that, I'm all the way up, above my user directory. This is as far up as I can go. Another shortcut that's useful is the tilde, a little squiggly on the top left key there. And that'll take me to my user directory. So if I switch directories and use that tilde, it'll take me back to my user directory, GDAL. Let me clear that out for you guys. And also if you hit up, it'll take you back to the last command. And if you keep going, it'll just keep taking you farther back. So if you want to repeat a command, you can use that. So that took me into my user directory there. So it's pretty basic, but this is really all you'll need to do most of the GDAL and the OGR functions. One last thing. So I mentioned that bash profile file. It was a dot file, so it was hidden. And when you install GDAL, the README in there is going to describe something that you need to do in order to get it to work. Basically, at the command line, your computer is only going to look for things in your present working directory. So if I'm in my user directory right now, and let's see what's inside of here. Oops. So if I'm in my user directory, let's say I go into documents, and I want to try to open up pgadmin.log. So that file is in my user directory. I've already navigated now down below that to my documents directory. If I try to open that up with a text editor like Nano, oh, actually that was a bad example because Nano will just create a new file. But if I try to access that just maybe by typing it in, it'll say it's not found. There's nothing in the documents directory with that name. And that's because the shell will only look in my present working directory for things. It'll only look there for files. It'll only look there for commands, with a few exceptions. So this could be a real pain in the butt, because what it means is that we might have to specify the full path for everything that we wanted to use. So if I had a file in a folder inside of my documents, or if I had a utility in there or a program in there that I wanted to access, I'd have to type in the full path to that. I'd have to type in something like users, GDAL, documents, and then maybe I have my OGR demo folder, and then inside of that I have another folder, and I have to access it like that. So sometimes you'll have to do this with files, and it's just kind of the way it is at the command line. But if you're using something like OGR all the time, you don't want to have to type in the full path to that utility every time you want to use it. And the full path to that, just to give you some sense, the GDOL programs, I'll pull this up here. So this is the path to the OGR to OGR tool that we're going to be using. And this would be kind of a pain to have to type in every time that you wanted to use it. So the computer has a way around this. On Macs, it's called the path variable. And in Windows, I think it's called the environment variable. And that variable basically holds paths in it that the computer can search for things. So what it'll do is when you tell it to, let's see here. If you tell it to use the OGR to OGR command line tool, what it does is it first looks in the present working directory and it says there's nothing called OGR to OGR there. And then it goes to your path variable or your environment variable, and it says, okay, it's telling me to look in my /USR folder, and it looks in there and it says, okay, it's not in there, and then it goes to the next one. So the path variable holds all of these different paths that the computer is going to search for things in. So we can use this to make it a little bit easier on ourselves. We can add paths that we're going to use a lot to that path variable, and then the computer just automatically knows to look there. And the way that we do that is in the .bash profile file. So I'm going to go back into my user directory. Oops. So I'm back in there, and that one's not going to show up in the normal ls command. But remember, there is a file in here called .bash profile. And if I open that up with a text editor on a Mac, it's going to be something like nano or vi. I can open that file up by typing nano bash profile. And that opens it up in a text editor here. And all of these export statements are basically telling the computer to add these paths to the list of search paths. And there's a bunch of them in here. These are mostly for Python libraries and other things that have been installed. But you can see up towards the top, there's the GDAL library path. And this is the thing that you'll probably need to add when you first install GDAL, is this statement right here. And basically what this is saying, export basically means to save a variable. And so you're taking your old path variable, which is represented by this $sign path right here, and you're tacking on a new path on the other side of that colon there, which is the path to GDAL right there. You're saying, okay, set my new path variable equal to the old one with that tacked on there. The syntax of this is super important, because if I went in here and I did something like I didn't put on this old path variable, I just said, okay, make my new path variable equal to this, just the path to GDAL. Then it erases all of the other stuff in my path variable, which means I can't use the ls command because that was in my path variable. I can't use the cd command. I can't use the pwd command. Those are all already in there automatically. So if you go in and change this, it's really important that you get the syntax right and make sure that you tack it on to the old variable there. And this is all in the GDAL README. So if you go in there, it actually has it written out exactly what you need to paste in here, and it makes it really easy. But just good to know that you don't want to mess that one up. Awesome. So that has already been done on my machine, so I'm not going to go through that. Okay, so those are some command line basics. Let's get started with some actual OGR stuff here and learning how to use that tool to do some conversions. So this is going to be the basic syntax, the basic format for using the OGR to OGR tool at the command line. And this is kind of a general pattern for most command line tools. You're going to have the command that you want to execute first, and then there might be some options, which are usually represented by these flags with a dash in front of them. So we've got this -F, which tells it the format. We've got this one over here. In general, you don't need to worry about the positioning of the optional arguments. Sometimes you do, but in general, it doesn't matter too much. But then you have what are called positional arguments. So these don't have any kind of a dash flag in front of them. And the way that OGR knows what to do with these is by their position after the command. So these have to be in the right order. And for OGR, we're going to have the file that we want to output first, and then the file that we're actually converting after that. So this will probably be most of the options that you'll use for most of your OGR work, which will be the command. You'll tell it what format you want. You'll tell it the file name. You'll say which one you're reading into to convert, and then you might give it like an option to reproject it or something over there. So that's the basic syntax there. And I'll demonstrate a few conversions here so that you guys can see what that looks like. And actually before that, maybe I'll show you guys a couple of these. And these will all be in the slides. It'll be online too. So the conversions that I'll go through are converting a GeoJSON file to a shapefile, doing the opposite direction, shapefile to GeoJSON, and then how to get data out of Postgres into a shapefile. And then we'll also talk a little bit about KMZ files. These ones are a little bit weird. OGR can deal with KML files just fine. KMZs are actually zipped versions. And I'll talk about it a little bit later. They require a little bit of extra work though. All right. Great. So I'm gonna go into the directory that I set up all the data for this demonstration in. It's gonna be in here. So again, I'm just using the cd command to change my directory. And go into that one right there. So now I'm in that new directory. You can see what's in there. I have a few different folders. No files in here, just directories. And so one of the things that I often do when I'm doing command line work is I like to have a text editor open. I usually use Sublime. And this is nice because at the command line, it can be really hard to, if you make a mistake somewhere early on, you actually have to scroll, get the cursor all the way back there to edit it. In a text editor, you can do things like select the whole thing and do replacements. It's just a lot easier to work with, and then you can just paste it in at the end. So to start with, let's try doing a GeoJSON to shapefile conversion. So I'm just going to copy and paste that whole command in there. I'll go back in here and paste it into my terminal. So what this is saying is it's saying use the OGR to OGR tool to create this schoolsdata.shapefile inside of the data folder. That's why it has the data / schoolsdata.shp. And to create that from schoolsdata.json. And you'll notice in this one, there's no format specified. And that's because OGR by default will try to convert things into a shapefile because that's what most people want. So if you don't put anything in there, it'll try to turn it into a shapefile. So, oops. Oh shoot, I think I forgot to put that back in there. Let me try that one more time here. So let me try this with the format specifier and see if that does any better. Oh, sorry, you know what, I just realized what happened there. I was working with this earlier and forgot to delete the file. So OGR won't actually overwrite a file unless you tell it to. So when I was doing this earlier, in the data file, I created that shape file already. And so now it won't overwrite it. So I'm gonna come in here, delete that one. And we'll go back and try that again. Oh, and usually, so typically when it spits this out, it means that there was some kind of an error. It's spitting out all those different file formats there. Let's see if I can find where that one is. Actually move that to a different spot. Okay, I think I actually deleted that file by accident earlier. So let me try this. We'll do it the opposite direction. We'll actually start off with doing a shapefile to GeoJSON conversion, and then we'll do it back the other way. So for this one, I do need to specify the file type. I'm going to use that -f flag and specify that I want a GeoJSON. I'm going to tell it where to save it right here. And then tell it which file to pull from right there. I'll actually fix this up a little bit here. Okay, cool. So if I want to take, let's say I want to do the airports layer that I have in there. I'm going to tell it convert to GeoJSON, call it airports.json, and pull it from the data/airports shapefile right there. When you're working at the command line too, you can use these backslashes to break up your command over multiple lines, so you don't have to type it out over one long line there. And that's what that is right there. This is capitalized. Okay, so that's what it looks like in the command line there. Make sure that all looks right. Enter, and since we didn't get any messages back, it means that it worked. And if we come into that folder, I saved that into the GeoJSON folder, so we can see that that JSON file is in there now. And if I want to, I can open it up and see what that looks like in there. That's what that JSON file looks like. So if I want to go the other way, we'll just do this right now. I can tell it to take the airports file. Actually, I want to save this as shape file. I'm going to take it from the GeoJSON folder, airports layer, and I'm going to turn it into a shapefile. And again, I don't need the format specifier in this one because it's going into a shapefile. Oh God. Oh, so it looks like there was some sort of a error in there. So actually, one of the nice things about OGR is when you do have issues with the files themselves, it'll sometimes tell you what they are. And so for this one, we can actually, it looks like one of the features wasn't translating. So let's try skipping failures. See if that works. Oh. Oh, I'm sorry. That was my fault. And this is one of the things that can be a little bit tough about using OGR. The syntax has to be totally perfect, and I left the S out of that folder name there. I suspect that was what the issue was. Yeah, so it was telling me it couldn't open up that file because it didn't find the directory right there. So that one just converted that airports JSON into a shapefile, and you can see that that showed up over here in that shapefiles directory. Yeah. Awesome. Yeah, and if any, I know we're going a little bit late, so if anybody needs to leave, feel free. So that's one common conversion: GeoJSON to shapefile and back again, or I should say the other way around: shapefile to GeoJSON. That's another common one as well. We can also do conversions from Postgres databases, and so if you are doing some of your GIS work with PostGIS in a Postgres database, you might want to pull that out and turn it into a shapefile, or you might want to pull it out and turn it into a GeoJSON so that you can integrate it into a web application. And you can do that too. The syntax for this is going to be a little bit longer because you have to tell OGR which database you're looking in, which table you're looking for, what the username is, stuff like that. And this is where the username becomes important. So in this one, we're telling it to use the OGR to OGR command. We want it to create a shapefile in the shapefiles directory called bocoschools.shp. We're giving it all of the parameters it needs for Postgres, so where the host is, what the user is, passwords, database name, stuff like that. And then we're also telling it within Postgres what's the schema and what's the table that I want to pull down. If you don't give it that, it'll, if it can, it'll turn all of the tables in that database into separate shapefiles, which you probably don't want if you have a really huge database. So you have to remember at the end there to put in the specifier for the table and schema. So let's try pasting that in. Make sure that that all looks okay. And this one generated a few warnings. It still ran correctly. It didn't show any errors. But these warnings are because there were some fields in Postgres that were longer than what's allowed for an Esri shapefile. And so it's just telling us that it cut those down to a different size. So if we look in that directory, that shapefiles directory again, we've just pulled that table and turned it into a shapefile here. And we can actually see some of these shapefiles if we want to look in QGIS and see what they look like. We just navigate into that directory. That's the shapefiles directory. Open up that one. And then zoom to the layer. And so that's the shapefile right there. I just pulled it out of the database. So those are the two that I probably use the most, are Postgres and GeoJSON. And between those two and shapefiles, that probably represents the bulk of the OGR work that I do. I think for now I'll probably skip the KMLs and KMZs. Basically, and I'll have these on the slides if you guys want to take a look at them. KMZs, what you have to do is actually save it as a zip file and then use your unzipper on your computer to unzip it. And then there'll be a file in there called a doc.kml, and that's what you actually convert with OGR to OGR. If it's just a regular KML, you can just use OGR like you normally would, and just convert it normally. So I think I'll skip that one for now though, since we're a little low on time. But maybe to wrap up, there's a few other conversions that I have that'll be in the slides. There'll also be a few other command line utilities in the slides that might be useful for doing things like getting data out of Postgres. But one thing that I wanted to show you too was just why these command line utilities are so powerful. And part of the reason is, so for starters, you know, in order to convert these shapefiles and GeoJSONs, I don't need to open up a whole application. I don't need to open up ArcGIS and find the tool and enter it in. I can just do it at the command line. And once you have the syntax down, it goes very quickly, which is great. But where it becomes really powerful is that you can incorporate this into scripts. So if you have 1 million shapefiles that you need to convert, if you can find a pattern, you can use OGR to just automatically loop through all of those shapefiles and convert them all into the format that you want. You can also use it to reproject them if you need to too. A lot of times for that, people will use the libraries that come with GDAL. So if you download the GDAL framework, you also get all these Python libraries, and if you're a Python programmer, you can use those to do this scripting. But I wanted to show you, this is just a pretty simple script that I wrote to take all of the shape files in a particular directory and convert them to GeoJSON, and also to reproject them into WGS84 projection. And this is written in Python. There are ways to actually just do it in your shell with bash scripting. I usually just use Python because I'm familiar with it. But really the meat of it is down here where it uses the OGR to OGR command to convert those. This one actually clips them as well to a certain area and then reprojects them into EPSG 4326, which is the WGS84 projection, or spatial reference. And it does a couple of other things here just to deal with some formatting issues. But this is a pretty simple script. Like, you know, this takes 5 minutes to write. If you know a little bit of scripting, you could probably figure the whole thing out in an hour if you needed to from scratch. And if you run it, this one will actually take all of, let's see here. So this is the command line right here. So if I run that Python script at the command line here, and in general, if you're running Python scripts, you just use the Python command, tell it which script to run, and then give it whatever parameters it needs. So this one is just telling the shell to take data, all the shapefile data from that data folder, write it to GeoJSON, clip it, convert it to WGS84, and save the output GeoJSON into this served assets data folder. And I'm actually going to just check which directory I'm in. A lot of times when I'm working at the command line, I just need to sort of constantly remind myself which directory I'm actually working in. Okay, so that's the one I want to be in. I'm just going to change some of these paths because I'm in a different working directory here. Oops. And for that one, I accidentally put that / in there, which meant it looked in the root directory and tried to find the data folder, and that wasn't in there. So this one's converting all those shape files. This is all the airports for the whole state, all the cities for the whole state. This is all CDOT data. It's taking them, it's clipping them down to Boulder County, and converting them over to that format. So that's pretty quick. Nine shape files. It happened in a matter of 7 or 8 seconds, and we can actually see these if we want to. So this is just a leaflet viewer that allows you to view GeoJSON files. Okay. So, and basically what this application is doing is just pulling all the files from that data folder that I just put all the GeoJSONs into. And so we can see it converted all of those airports, cities, highways, lakes into a GeoJSON format and did that. So this is where GDAL is really powerful, is that it allows you to automate this stuff. You don't have to do it in a model builder. You don't have to do it by hand. You can do this really quickly, and you can actually just run this in the background. You can get your script going, convert a few thousand shape files, go off and do something else, and come back when it's done. So unfortunately, I think I don't want to take up any more of people's time here because we're over by a little bit. But I do have some other slides that I'll put online with other conversions. I do want to show you guys one thing too, which is this website right here, and this will be in the slides. This is something that Boston GIS put together, and it's a cheat sheet for OGR to OGR. This is basically how I learned to use this tool. They have some just common conversions like Postgres and shapefiles and things like that. And when you're starting off, sometimes it's easiest just to copy this stuff, change around the parameters, and then enter it in, troubleshoot it a little bit. That way you don't have to write it all from scratch. So this is a really good resource. The GDAL website has some good documentation too. There's another tool that I'll have in the slides that is SHP to PG SQL. And that one actually allows you, it's designed specifically to take shape files and put them into Postgres. It's sometimes a little bit easier to use than OGR, and it allows you to name the geometry column and things like that. It gives you a little more control over it. If you're on Windows, there is this thing called OGR to GUI, and this is a graphical user interface for OGR. So you don't necessarily need to use OGR at the command line. You can use this interface if you're running Windows. I don't think they have it for Linux or Mac. The caveat for this one is that the people who created this are no longer supporting it, which means that as new formats come out, they're probably not going to update the GUI to keep up with the GDAL library. So you may not have all of the available formats in the future unless somebody else takes it up and decides to maintain it. I've also had issues with it. I mean, as with most GUIs, sometimes crashing, sometimes it works, sometimes it doesn't. Dave Murray did have an experience though where he was unable to convert a KMZ file at the command line, and this thing worked okay, probably because they built in some extras with this GUI too. So it's worth checking out. If you're having trouble at the command line, this might be a good place to start too. You can use that. And then, so I mentioned the PG SQL to SHP and SHP to PG SQL. Those are some other command line tools. Once you start getting comfortable at the command line, there are a ton of tools available out there. And the reason is it's just way easier to develop a command line tool than it is to develop the tool and then develop a graphical user interface on top of it that's intuitive and that works and that people can figure out how to use. So a lot of times if people are just developing stuff on their own time, they'll just do a command line utility. And that means that there's just loads of them out there available to use. One of them that I've found really useful is this topo.json command line utility. And this is actually something that Mike Bostock, who's a sort of a data visualization guru, has written. And basically what it does is we have the GeoJSON format that people use in web development all the time. but that GeoJSON duplicates geometry. So if you have, say, the state of Colorado and the state of Utah, in a GeoJSON file, their border is going to happen twice in that file. And that leads to a lot of extra data and a lot of information that you don't need. And so TopoJSON takes all those things out and uses topology to make the files more efficient. And the CommandLine utility allows you to take things like shapefiles and GeoJSONs and convert them into that more efficient format. So it's an interesting one to check out if you're getting into any kind of web development. Yeah, and sorry we went over time. I guess if anybody has any questions from the remote end, feel free to type them in the chat window. Do you guys, I don't know if you guys have any questions here. Yeah. Yeah, good question. So for folks that can hear that, the question was like we're working internationally or with Italy, do you see any difference in the file types, proprietary file types or other file types? And I actually don't work a ton with Dr. Brivelli in Italy. Raphael has worked with her quite a bit. I've done some work with some international organizations through the Renewable Energy Lab where I'm interning. And what I found is that they tend to use open formats more than we do over here. So Esri is just not as big a thing in most other countries. And so they tend to use things like GML, GeoJSON to a certain extent. They use shapefiles quite a bit too. But I've never run into an issue where I've seen a proprietary file type from one of those organizations that we couldn't use. Yeah, it tends to be more open formats, I would say. Great. Well, thank you guys for joining. We'll be posting the video sometime in the near future to the website, and keep your eyes out for some future events. Great, thanks everybody.